Suppose I have a regular 8 by 8 chessboard. I'm going to put 8 rooks on the board, but I have to follow some rules. None of the rooks are allowed to be on the main diagonal. The other diagonal is fine. No 2 rooks can share a column, and no 2 rooks can share a row. For the chess players in the audience, my last 2 rules just mean that none of the rooks are allowed to attack each other. How many different ways can I arrange the rooks, while following my rules, assuming that all of them are identical? Until we find an answer, we'll call this the 8th rook number. What if the board is a different size? How many ways are there to arrange n rooks on an n by n board? What is the nth rook number? Let's start with a smaller problem. Suppose I found a way to arrange n-1 rooks on an n-1 by n-1 board. The number of ways to do this is the n-1th rook number. In this case, I found a way to arrange 7 rooks on a 7 by 7 board. If I add an 8th rook to the bottom right corner, then I'm breaking my first rule. But I can fix my arrangement by swapping the last column with any other column. To generalize this, there are n-1 columns which we have swapped with the new column. Does this give all of the legal arrangements of n rooks on an n by n board? Suppose I arrange the rooks like this, with the bottom and rightmost rooks diagonal to each other. I can try swapping the columns to get 1 rook in the corner and a legal arrangement of n-1 rooks like before. But then we end up with both rooks on the diagonal, which is illegal. It's beginning to look like our counting method is completely wrong. However, all of the n-2 other rooks are still following the rules. What this means is that our current formula fails to account for legal arrangements derived from size n-2 boards. How many exactly? Well, our rook pairs can swap with any of n-1 positions, so there are n-1 ways to derive a legal arrangement from an n-2 board. Our new formula, with a little bit of simplification, gives that the nth rook number is equal to n-1 times the sum of the n-1 rook number and the n-2 rook number. Now, finally, we return to the original question. What is the 8th rook number? Let's start small and work our way up. There's no way to follow our rules for a 1 by 1 board, since the only square available is on the main diagonal. So the first rook number is 0. For a 2 by 2 board, we have 2 safe squares and exactly 2 rooks to fill them. So the second rook number is 1. For the 3 by 3 board, our formula kicks in, and we know that the third rook number is 2 times the sum of the first rook number and the second rook number. That is, 2. Likewise, the fourth rook number is 3 times the third rook number plus the second rook number. As such, it is 9. We can populate the whole table in this manner. Each row is the sum of the previous 2 rows times the value of n for the previous row. Finally, we get to the 8th rook number. There are a whopping 14,833 ways to arrange 8 rooks on an 8 by 8 chessboard, such that none of the rooks are on the diagonal and no 2 rooks attack each other.